Okay, looking at this thing, I would definitely, wonder about the bottom. Is it factorable? And let me write this down for you. So equals 1 to 2, and then what do you get? 1. It's quadratic in form, by the way. And I'm hoping for something really easy. It looks easy. So let's see, what are you going to get? Plus 2 minus 1. Does that work? You do get x squared. You get an x in the middle. Yeah, that works beautifully. I'm going to say partial fractions, but I do have troubles over here. I want to find out what the troubles are. I have divisions by 0 at 1. So 1 is trouble. 1 is trouble. The 2 is not trouble, but 1 is trouble. We'll put the limit down later. But I want to do partial fractions, right? So I'm going to say x minus 1, and then I'm going to say x plus 2 dx. I'm going to say I have no idea, and I'm going to do the work. And what do I know? I know 1 over x minus 1 times x plus 2 is equal to a over x minus 1 plus b over x plus 2. Multiply both sides by the LCD, you get 1. Then you're going to get a, x plus 2. Then you can get b, x minus 1. Pick an easy x. I'm going to say x to be 1. That's easy. What do you get? 1 equals 3a. That means a is 1/3. Give me my eraser out, and I'll put the 1/3 down. All right, let's try to see get the b, and the way I'm going to do the b is I'm going to pick x to be minus 2. What does that give you? Well, 1 on the left side. On the right side, what do you get? You get minus 3b. So b is minus 1/3. Let me get my eraser out and put down minus 1/3 now. I'm going to factor out a third. I'm also going to write the limit now. Limit as a. Don't use x, by the way. Any letter but x in this problem. So a goes towards 1 from the right side. A to 2. I factored the third out already. X minus 1 minus 1 over x plus 2 dx. Let's write down the antiderivative, and we're evaluating this thing. So 1/3 limit a goes 1 to the right, and this is going to be, let's see, the natural log of the absolute value x minus 1 minus the natural log absolute value x plus 2, and that goes from a to 2. Let's write this down. 1/3 limit. Oh, let's do it. 2 minus 1 is 1. The natural log of 1. Let's write it down. Minus, I'm evaluating 2, by the way. 2 plus 2 is 4. That's done. Minus. Now I'm going to write this as a quotient. Limit, I'm sorry, not limit, the natural log, a minus 1 over a plus 2. All right? Oh boy, that looks tough. Not really. What are we going to get? We're going to get, well, this is 0. This is just simply minus natural log of 4. I'll write that down, by the way. Over 3. And then we get, let's see, minus 1/3.
The plus sign plus and the minus sign are mathematical symbols used to represent the notions of positive and negative, respectively.
Whoops.
Do you want me to keep reading?
No. Siri's talking to me now. She listens sometimes. Let's see. I forgot to write it down.
I'm not sure I understand.
1/3 limit. A goes to 1 from the right side. And that's going to be the natural log of the absolute value a minus 1 over a plus 2. Let's take a look at that. I'm sorry, I have to get my pen is really acting up on me. Okay, let's keep going. What do you get? Minus the natural log of 4 over 3, minus 1/3. And then I got to think about this. And as a goes towards 1 to the right side, I'm going to get 0 over, it's the absolute value of it, so it really doesn't matter what I'm doing. But it is 0 from the right over 3, so it's 0. So the natural log of 0 from the right side is going to be minus infinity, all right? So I'll write that down. And what do you get over here? Infinity, all right? What do I know about this thing? It diverges. All right, so I think they provide a picture for us. I do notice there's an error in my key, by the way. I want to tell you what the error is. I forgot to write this down, but I will correct this, right? Now, when I say that, if I remember to correct it, that's another issue, right? But anyway, we got the answer, infinity. Work looks pretty good. Oh, you know what? I didn't forget it. I'm sorry. I thought I forgot it. I didn't forget. I put it in there. How did I do that? I multiplied through by the, the minus the natural log of 4 would simply be 1 over 4. So I did it. I didn't forget it. I'm sorry. I thought I forgot it, but that doesn't need to be corrected. I'm fine. Now, certainly someone says, did you have a picture of this thing over here? And I believe we have a picture of it. It says figure 8, page 59. A picture of what? A picture of, let's take a look at it. I got to make sure I'm doing the right thing over here. Where's my problem? A little confused right now. Where did the problem go? Oh, I'm sorry. It's right. I'm staring at it. It's right here. I didn't see it. I hate to tell you that. My writing's all over the place. I didn't see it. What did I do? I graphed the integrand. Let's take a look at it. And when I do it, I'm not going to say it gives me much information, by the way. Let me make sure I'm doing the right picture, by the way. So figure 8, page 59. This is figure 8, and it's on page 59. It's right over here. All right? So I'm looking at, all I know about looking at this picture over here, and really, this is above the x-axis. I see that. And I see the numbers between 1 and 2. And I see something, strange happening at 1. The thing's shooting off to infinity. I don't know this area, though. I had to figure it out. I can't look at that and tell you it's infinity. But when I did the integration, that's an infinite, unbounded area. It's a divergent integral. Thank you.